Well, hello everyone. This is KP the Math G here. I was wondering if I'd get to do another video, and I'm going to be able to at this time. I'm going to divide this video up, I want to say, into two parts. This is question A, and I want to look at B and C probably together. I'm not sure yet, but yeah, I believe we can do B and C together. This, by the way, as you can well see, is the 208 AP Calculus AB test. The free response is question number 3, which says, and excuse my, I hope this is bright enough for you to see. My pens are getting dull a little bit at a time. I have a bunch of them, but still they're all getting dull at the same time, getting dim. So bear with me. I hope you can see this all right. Oil is leaking from a pipeline. The volume increases at a, and it's into a, well, it's in the surface of a lake, okay? And the volume increases at a constant rate of 200 cubic centimeters per minute. It takes on the form of a right circular cylinder. At the instant the radius is 100 centimeters and the height is 0.5 centimeters, the radius is increasing, and it's at a constant rate of 2.5 centimeters per minute. At this instant, what is the rate of change of the height? I've been looking for a related rate problem, and lo and behold, I found one. So we're going to work on this. Now, let's consider, first of all, I've got so many things over here, what the volume of a cylinder is. Alright. The volume of a cylinder is given to be pi r squared h. Now, when you do a related rate problem like this, you need to know what's what. Now, first of all, we know that the volume increases at a constant rate. So when I see the word rate right here, that's dV over dt. All right, so we're going to label everything here. So dV over dt is 2,000, and I'm not going to put the units there, just leave it like that. That's the rate of the volume, okay? All right, it takes the form of a right circular cylinder. We've already said what the formula for that is, okay? At the instant, the radius is 100, so we know that at that instant the radius is 100 centimeters. The height is 0.5 or 1/2 of a centimeter. Alright. The radius is increasing. Alright, increasing at a rate. So what's increasing at a rate? The radius is increasing at a rate. What is that, guys and girls? Yes, or ladies and gentlemen, if you will. Yeah, that is the rate. All right, so that would be dr over dt, which is 2.5, and of course centimeters per minute. Now the height, we want the rate of change. What are we looking for? The rate of change of the height. So what are we looking for? Yeah, once again, that's right. dh over dt. We have everything but that. Now, when we flip this over, can we see that we can go ahead and take the derivative of this and get the answer? How are we taking the derivative of this? Now, and we know we have to take the derivative because we need to find dv. We need to, sooner or later, substitute dv dt, dr dt, r and h in for all of this. Okay. Okay, so that's what we're looking for. Alright, I had something else on my mind, but probably it'll come back to me in just a little bit. But at any rate, we're going to have to take this derivative. Oh, what's the method for doing this? Yeah, that's right. If I could just hear you say it, you probably said it before I even had a chance to finish the question. Yeah, this is the product rule, isn't it? Alright, so let's flip over. We might have to go back and forth flipping over, but let's see if we can do this on the other side of the board. I think we have plenty of room on the other side, but alright, let's see, right here. Alright, so we have V. The volume is pi r squared h. Alright, let's go ahead and integrate this. Alright, not integrate, but find a derivative of it, I'm sorry. Alright, here we go, right here. dv over dt. Alright, I'm going to do it this way. The first times the derivative of the second. Derivative of h is 1 times dh over dt, which we're looking for. Okay, like that. Alright. The first times the derivative of the second plus, alright, the derivative of the first, or the second if you want to, the second times the derivative of the first. Alright, the second is right here, it's h, times the derivative of the first, which is 2 pi r dr over dt. Taking that 2, I just put the 2 in front of the pi right there, making that 2 pi. And now r, then tack on the dr over dt. And you know, if you get this, this is it. Okay. Alright, let's go ahead and plug in the numbers. We have everything. dh over dt, I want to say, is 2000. And we'll double check this. Alright. Pi, now the radius is 100 at that instant. dh over dt is what we're looking for. Alright, we know that the height at this instant is, I want to say 0.5 times 2 pi times r. Now r, I want to say the radius is, that's what we had a while ago, is 100. So 100. Alright, dr over dt is 2.5. And that's the instant that we were looking at. The instant that this is 2.5. What is this right here? Okay. Alright, let's look it up just to make sure. let's see, I want to say dV over dt 2000. R is 100. Well, I'll leave off the, for lack of space, I'm just going to leave off the units. The height is 0.5, and dr over dt is 2.5. I do believe everything is in order. Let's just double check, because I don't want to go through all this and miss this now. I know you don't either. dV over dt 2000. Got it. R is 100. H is 0.5. dr over dt is 2.5. Okay. And this is what we are looking for. Okay. Everything is in place. Alright, let's do it. I'm going to do it by hand. Alright, now remember, you square something with two zeros, just double the number of zeros. You got it. 1, 2, 3, 4. Alright. dH over dt plus, alright, let's see, half of 2 is 1, so that really just goes out. So 100 times 2.5. Okay, so just move the decimal over. So 100 times 2.5. Just move the decimal over 2 spaces, I think. And I want to say that is 250. I do believe that is correct. 250 pi, right? 250 pi. Alright, I do think I got everything correct. Alright, let's see. Alright, well, one thing you can do is, once you figure this out, I've got so many papers here. Let me see if I didn't put it on another note. I've got several note, I got pads and pads of paper here, so I'm trying to see where I might have wrote that out. Okay. I think this is alright. Okay, well, alright. Let me double check. I just want to make sure I'm right. Okay. Yep, okay. Everything looks good here. I do believe everything is alright. Alright, so now I'm going to subtract this off. Alright, so 200. And if I subtract this off on this side, it's going to be, alright, well, let me erase this. I'm sorry. So minus 250 pi. Alright, so this left side is 2000 minus 250 pi. Alright, is equal to, and I can put the pi on the end here, 10,000 pi dH over dt. Alright, that's just a matter of arithmetic now, isn't it? Right? We're going to, this is multiplying, so we're going to divide by 10,000 pi. 10,000 pi. Now at this level, do not make a mistake and just say, well, I'm going to divide all pi's. You don't have a pi over here, so leave that as is. And I want to say that dH over dt, alright, I want to say, let's see, let's get our calculator out for this one. So my calculator here, TI-84 Plus, it's an old calculator, but I do have the actual value of pi, so I'm not putting in 3.14. I hope your calculator has the same. Alright, so anyway, 2,000 minus 250 pi. Okay, I'm going to, right, divided by, okay, 10,000 pi. Alright, 0.03866. 0.03866. 0.03866. I think that goes on. Well, so let's see. In calculus, you can take the first three. So 1, 2, 3. You can make that 39 if you want. So about equal to. Well, this is actually about equal to anyway. All right. All right. So somewhere around 0.3, and if you want to make it 387, it doesn't matter if you go too far. You just don't want to have two left. You don't want to round this to 0.04. All right. So something like that. dH over dt. Alright, and I want to say that if I look at that, yeah, so both answers. Oh, by the way, we need to put that in the units now, and yeah, I'm sorry about that. We do need the units. That is in centimeters per minute. Centimeters per minute. dH over dt. Alright, there it is. I know sometimes you have to, sometimes we do an R over H equals R over H, or H over R is equal to H over R. You can do that. Don't do that here. You've got everything but dH over dt, and you can just go ahead and figure this out. Okay, sometimes you can set up a proportion, and here you don't have to do that. Matter of fact, I would recommend you not to do that here. Okay, just go ahead and take the derivative all the way through, substitute everything in except for, of course, this, and then solve, and you got it. Alright, well, I had a feeling. What I wanted to do was find a problem that was dealing with a related rate, and hopefully somewhere down the line is one of those ladder problems. If you hear me say ladder problem, if you've taken calculus, you know what a ladder problem is. I'm sure you do. So anyway, the idea is, and before I stop, I do want to say one more thing. Which is which? Okay? The volume increases at a constant rate. dV over dt. Volume, the volume's rate. dV over dt. Right there. There it is. Right circular cylinder. I need to know that. V is equal to pi r squared h. Okay, if this was a cone, you would say 1/3 pi r squared h. Okay, and so on. Alright. Takes the form of a right circular cylinder. At the instant, the radius is 100. So r is equal to 100 at that time. At that instant. Okay, and the height at that instant is 0.5 or 1/2 centimeter. Then the radius is increasing, and it's supposed to say at a constant rate of 2.5 centimeters per minute. So what is that? Radius, what's it speaking of? The radius, the rate of that radius. There is your dr over dt right there. Alright, what is the rate of change of the height? That's dH over dt. And part 2 of this, you've got to remember that I think in this problem they did give you the formula, okay? But you might want to memorize that, alright? So, product rule. When you integrate, I've been doing integrating so long, I say integrate all the time. When you take the derivative of h, dH over dt, take the derivative of volume, dV over dt, take the derivative of radius, dr over dt. So the first, put these two together, okay, times the derivative of the second, plus the second times the derivative of the first. Plug the numbers in, okay, and then simply solve. Alright, that is all I have for this time. Like I said, the other one is going to take a little time, and I'm sure I would run out of time if I try to do parts B and C. So I want to put B and C together and just work that out on a separate video. But I do appreciate you watching my videos. I appreciate your confidence in me, because I'm going to tell you something. I'm going to give you my best. I'm going to give you my all, okay? And I'm going to try to the best of my ability that's been given to me to explain this in a way that's easy to understand. That's really what I'm about here, is to help you understand this easily, okay? Or at least more easily, okay? And so that is my purpose. That has been my purpose throughout my teaching career, is to try to make things more easy or very easy to understand. Well, having said that, I don't bring any glory to myself. I just want to help you get better, okay? And it helps me when I study this. Believe it or not, I even gain from it. Well, anyway, that's my spiel for this evening. And once again, I appreciate everyone here who is listening, even if it's just one person, but I do appreciate you very much. If you have not subscribed, please subscribe if you want to, but I would appreciate it if you would subscribe to my YouTube channel. And then if you'd like to make a comment, please make a comment. Feel free to make a comment. And if you want to hit that like button, please hit that like button. I appreciate everyone who is tuning in and watching my videos. I've had some people say I appreciate your videos, or keep it up, keep doing what you're doing. That really encourages me so much. So anyway, this is KP the Math G signing off for now, and I'm going to do my signature clap that I always do. That's just something that I thought of, and I just like doing it. KP the Math G signing off. Have a great, great day.